Hi everyone, so this video is going to cover a number of sections out of your textbook and is sort of the everything you need to know about fractions. Much of this should be review for you, if not all of it. But let's dive right in. So we're gonna start with some vocabulary and some background about what fractions are. So fractions really is another way of writing a division. So if we're dividing a by b, we can write the fraction as a over b. And so that a, when you put it on the top, is known as the numerator, and the bar indicates division, and that might be a different way of thinking about fractions for some of you, but that bar means division. And so very soon in this year, the division symbol that you're used to seeing is essentially going to disappear, and it's going to be replaced with fractions. And so the fraction bar represents that division. And then the bottom number is, of course, known as the denominator. If the numerator is less than the denominator, then what you have is a proper fraction. If the numerator is greater than the denominator, you have an improper fraction. An improper fraction can also be written as a mixed number with a large whole number in front and then followed by a fraction. So what we're going to do first is we're going to look at how do I take an improper fraction and write it as a mixed number, and how do I take a mixed number and write it as an improper fraction. So the first one we see here, we have a mixed number, 3 and 4 over 5. If we want to write that as an improper fraction, that 3 represents 3 wholes, and then 4 out of 5 more. Let's say more. So if each whole is represented, it would be 5 pieces, then we would do 3 wholes times those 5 pieces would give me 15 pieces, and then an additional 4 to give me 19 out of 5. So essentially you take the large number, multiply it by the denominator, and then add the numerator, and that becomes your new numerator. Denominator stays unchanged. So 19 over 5 would be how we write 3 and 4/5 as an improper fraction. So going the other direction, if we have negative 17 over 3 and we want to write that as a mixed number, we're going to go 17 divided by 3. How many times does 3 go into 17? So it goes in 5 times, because 15 is 3 times 5. So we get 5 wholes, but then if 3 times 5 is 15 and we actually had 17, there are 2 more left over, and then the 3. And then this is negative because it was negative 17 over 3. So again, I am assuming that you have done this before, you have seen this, this is not new. So if the fraction bar is another way of writing a division, let's talk about how we evaluate fractions. So this first one, write as a division and hence evaluate. So we would do 54 divided by 9, and this one actually works out to a nice neat whole number, giving us 6. So evaluating that gives us 6. If we look at the second one, write that as a division, so that becomes 16 divided by 40, and then we would probably grab a calculator on that one. 16 divided by 40, and that gives me 0.4 or 4/10. So that's how you change fractions into decimals. You just do numerator divided by denominator, again, because that fraction bar represents division. Okay, now we're going to talk about equal fractions. So you can write fractions in different ways with different denominators and have them be equal, provided that the numerator changes in the same way that the denominator changes. And one of the biggest practical applications of that is this idea of writing fractions in lowest terms. Whenever you write a fraction, from now pretty much till the end of your math career, you're always going to want to leave it in lowest terms. That is the best way to leave an answer. Math loves a simple answer, and the simpler you can make it, the more that math loves it. So every time you are working with fractions, you want to write it in lowest terms or simplest form with the smallest possible integer numerator and denominator. So if we look at this example of 10 over 25, in order to write this fraction in lowest terms, you need to find a common factor between 10 and 25. If you get the largest common factor, you can get to lowest terms in one step. If you don't get the largest common factor, it might take you a couple of steps to do all of the divisions to get all your way to lowest terms. But as I look at 10 and 25, I know that I can divide both of those by 5. They both have 5 as a common factor. Incidentally, it's also the highest common factor, but again, as I said, if you don't get the highest common factor first, that's okay. It'll just take you a couple of steps to get to lowest terms. So then I'm going to solve those divisions. So on the top, 10 divided by 5 would give me 2. On the bottom, 25 divided by 5 gives me 5. So 2 over 5 is 10 over 25 in lowest terms. Okay, moving on. So now we're going to talk about some operations with fractions. 4 basic operations that we're going to touch on: adding, subtracting, multiplying, and dividing. Normally I would start with multiplying because I find that one to be the easiest, but we're going to start with adding and subtracting because they work exactly the same way. So to add or subtract fractions, write, if necessary, the fractions with the lowest common denominator. So it doesn't have to be the lowest common denominator. It is easiest in the long run. If it is the lowest, it will require the smallest amount of simplifying at the end. But as long as you get a common denominator, you're fine. Again, you just may have to reduce it more at the end to put it in lowest terms. But this says lowest common denominator. Once you have a common denominator established, that denominator is the same in your answer, and your numerator is just adding or subtracting the numerators from the original question. So if we look at this first example, 3/8 plus 1/2. Obviously 8 and 2 are not the same, so I'm going to need a common denominator. So I'm looking for preferably the lowest common multiple. Lowest common multiple will be the lowest common denominator. Again, you don't necessarily have to get the lowest common multiple. It just makes it a little bit easier if you do. So looking at 8 and 2, I know that the lowest common multiple between 8 and 2 is 8. So I'm going to make my common denominator 8. Because I have not changed the denominator from the first fraction, my numerator stays exactly the same. To figure out my numerator for the second fraction, I have to look at what did I do to that original denominator to get to the denominator that was common. So what did I do to 2 to get to 8? What did I multiply 2 by in order to get 8? So I multiplied 2 by 4 in order to get my new denominator. Therefore, I must do the exact same thing to the numerator. So my original numerator was 1. I'm going to multiply that by 4, and that's going to give me a new numerator of 4 over 8. So 1/2 and 4/8 are equal fractions. So then once I've established my common denominator, my denominator will stay the same. I will add my numerators, 3 plus 4, to give me a final answer of 7 over 8. Great. Let's look at the next example. So this time we're adding and subtracting 3 fractions together. So I'm looking for the lowest common multiple of 4, 3, and 2. Worst case scenario, you cannot figure out a common denominator. Multiply everything together. That will give you a common denominator. So for this first example, I could have just multiplied 8 and 2 and got a denominator of 16. That would have been fine to use. I just need to make sure that my final answer is in lowest terms. Here I have 4, 3, and 2. I could multiply those all together and get a denominator of 24. I know it's not the lowest common denominator, but it's a denominator that would work. I know 4, 3, and 2, I'm going with a denominator of 12 because I know that 12 is common to all of those. 12 is a multiple of 4, it's a multiple of 3, and it's a multiple of 2. So then I need to address the numerators. So to get from 4 to 12, I multiplied by 3. So I need to multiply this by 3 as well to give me 9 over 12. To get from 3 to 12, I multiplied by 4, so I'm going to multiply that numerator by 4 as well to give me 8. And then to get from 2 to 12, I multiplied by 6, so I'm going to multiply my numerator by 6 as well to give me 6 over 12. Then once I have my common denominator, I'm going to go ahead and in this case use order of operations, although it's adding and subtracting, same level of order of operations, so I'm just doing them as I get to them. You could do it in one step if you wish, or you can do it in two. I could just focus on doing this part first and then add the 6, or I can just leave my denominator of 12 and go 9 minus 8 gives me 1, plus 6 gives me 7. Do a final check to make sure that 7 and 12 don't have any common factors, and they don't. If they did have a common factor, I could reduce that to lowest terms, but 7 over 12 is lowest terms in this case. One more adding or subtracting example. What do you do when you have mixed numbers? Well, you have to convert them into improper fractions first and then follow the steps from the previous examples with a common denominator, etc. So my first step is going to be to make these improper fractions. So I take the large number, multiply by the denominator, which gives me 4, add the numerator, gives me 5, so this becomes 5 over 2, minus large number times denominator, which gives me 5, add the numerator, which gives me 7, so that becomes 7 over 5. Now I need a common denominator between 2 and 5. I'm going to go with 10. So I multiplied my 2 by 5 to get to 10, so I have to multiply the top by 5 as well to give me 25 over 10. To get from 5 to 10, I multiplied by 2, so I need to multiply numerator by 2 as well to give me 14 over 10. So then, denominator stays the same. 25 minus 14 gives me 11 over 10, and I am finished. Unless the question specifically states to put it as a mixed number, it is a step that's not required. So I can leave that as 11 over 10, or if I really wanted to, I could make that 1 and 1 over 10. Unless the question is asking you to do that, you're taking a bit of a risk doing one further step, because if you make a mistake in that very last step that wasn't actually required or asked for, then you're going to end up in a situation where you're going to have an incorrect final answer. Okay, let's shift gears to multiplying fractions, which I think is the easiest of all of the operations with fractions because you don't have to change anything. So to multiply two fractions, we multiply straight across the top, numerator times numerator, and then straight across the bottom, denominator times denominator, and then simplify, reduce to lowest terms if you can. So looking at our first example, 3 over 7 times 2 over 5, I'm going to multiply straight across the top and straight across the bottom. So 3 times 2 gives me 6. 7 times 5 gives me 35. And I cannot reduce that. They do not have any common factors. When you're dealing with a mixed number, you need to make that into an improper fraction before you begin multiplying. So again, large number times denominator, 1 times 3 gives me 3, and then add the numerator, so that gives me 4 over 3 times 3 over 5. And then again, same process, multiply straight across the top, multiply straight across the bottom. 4 times 3 gives me 12, 3 times 5 gives me 15. Do 12 and 15 have any common factors? Yes, they do. So I'm going to divide top and bottom by 3. So 12 divided by 3 gives me 4. 15 divided by 3 gives me 5. Take note of how I'm completing these questions. I am working down my page, not across, no equals sign. That needs to be the method that you do in your notebook. And finally, dividing fractions. So to divide by a fraction, we multiply by the reciprocal of that fraction. So you'll see here a over b divided by b over c. A over b remains unchanged, and c over d becomes d over c. So we just flip the top and the bottom, we flip the numerator and denominator, and then the division becomes multiply. So what do we do if we have a whole number? How do I make a whole number into a fraction? Really simple, you put that whole number over 1 and you've got yourself a fraction. So we take first fraction, which is now 4 over 1. We flip over the second fraction, 3 over 1. Our division becomes a multiplication, and then we're doing just what we were on the previous examples, straight across the top, straight across the bottom. 12 over 1, reduce that to lowest terms. Anything over 1 is just itself. So my final answer on that first one is 12. Second example here, again, we have a mixed number, so we need to make that into an improper fraction. So 1 times 3 is 3, plus 1 is 4 over 3, divided by 2 over 5. And then we're going to leave our first fraction and we're going to multiply by the second fraction flipped over by the reciprocal of the second fraction. And then we're going to go straight across the top to give me 20, straight across the bottom to give me 6. Do we have any common factors? We absolutely do. I can divide both of those by 2. And that will give me 10 over 3. And then if you really want to and are confident that you are not going to make a silly error on that last step, we could make that 3 1/3. That's a lot of information, but that covers everything you essentially need to know in grade 8 about fractions and how to work with them and how to navigate through operations with them. So that's the end of this video.